Today is 9th of October 2020 and we will learn friction stir welding, or in short FSW. Okay, here this friction stir welding is a solid state process. That means the material does not get melt, and here mostly we join aluminium and often large pieces which cannot be easily heated after welding to recover temper characteristics. In that cases, we use friction stir welding. Suppose whenever we melt a material, the material when solidifies, it go through air quenching and it becomes brittle and very hard. So in that case, to restore its strength, we several times need to do heat treatment. We need to do tempering or normalizing. Okay, so we again need to heat the object and then we need to cool it slowly. Now the material which in which materials this normalizing or tempering process is not available or very difficult in such cases, and mostly in aluminium materials, the welding, this category of welding is done, friction stir welding is done. So here two parts are clamped rigidly on a backing bar in a manner that they will prepare a butt joint, but they will be fixed very rigidly. Now in that joint, a special type of tool having the pin at a particular profile, this is the tool looks like. This portion is called pin, is inserted while it's rotating. Now this is inserted in the job and this pin moves through the joint and the joint is produced. So that you better understand, we will show you a video, then the concept will be very much clear and it will help us in further discussion. Give me a moment. Frictions. Yes. No, this is not. Yes, this one. Okay, found it. Yeah. Okay. Look at this video. I'm playing it. Look at the machines. See, this is the pin getting inside the aluminium. Okay, now it rotates and moves, and the joining is being produced. Look, the pin is inserted in the joint. Now it's moving, and the joint is produced.
फ्रिक्शन स्टीयर वेल्डिंग तो
हाँ 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 हाँ. Look what is happening. Okay, now I hope you have understood the process. Now we can discuss here. This 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 portion is called pin or probe. And okay, how can we start? Okay, is process is clear. Process is very clear. Now let us discuss the advantages. Here, good mechanical properties are achieved. Now, as you see, this material is not getting melt, so it is happening on in a solid state. So that's why the mechanical properties are getting maintained, and because of small application of heat and very quick uh, cooling down, the mechanical properties we get is quite good. So requirement of other heat treatment process is not required. Now this here is extremely safe because here no ultraviolet rays are being produced, no toxic fumes are produced, no spattering of molten metal. So it is safe for the environment. I mean the for the shop and as well as for the operator also. Number three, there is no consumable electrodes or no consumable gases, nothing to be applied. This is a very good advantage. Now, little shielding gas in some cases will be working as sufficient. Not much required. In some cases, maybe some requirement of the little shielding gases. And the most importantly, it easily can be automated. That means time required is less, and time required is less, and as well as the accuracy you get is very good. Can operate in all positions, as we have seen, in a carved path, in a straight path, in a vertical path. Okay, this can operate in all positions. It can be done in a simple milling machine also. Fixing the job in the table and move the table for along the joint and rotate this this probe or this tool from a vertical milling machine, or in case of uh, vertical welding you can use a horizontal milling machine. So that is quite difficult, but still for straight jobs this can be done in simple milling machines. Okay, it has very good appearance, as you have seen in the video. Good appearance. And it has very low environmental impact. So these are its advantages. Now it produces the thermomechanically affected zone, because in this joint the zone prepared because of the frictional heat and the mechanical rotation produces the microstructures rearranged in a in a in a certain form, that the material get fused one into another, and thus this thermomechanically affected zone provides you a very good mechanical properties. So this is a very important term, T M A Z. If the question comes to write a few words or few lines about TMAZ, then you must remember this is thermomechanically affected zone. Okay, and this is available in friction stir welding process. Now we learn the limitations of it. The limitations are: the first problem is the exit hole left when the tool is withdrawn, and large forces are required to large forces are required. Also, heavy duty clamping is also required. Sorry, the large forces are required, also heavy clamping is required to hold the plates together. It is less flexible than other arc weldings or welding processes. Okay, so these are the problems. So this is a special type, not a large popular type one, because the initial uh, costing, if you require a separate machine, then the initial investment is higher. So in that case, if you require a mass production, then only go for a separate machine. Otherwise, if you need a very small job, then you can do it only with a simple milling machine, simple vertical milling. Now, have we discussed the FCW, the flux code arc welding? Have we discussed it? Please give me a response.
Sir, flux core.
Uh-huh. Flux code.
না স্যার হয়নি মনে হচ্ছে।
আচ্ছা ঠিক আছে, then we will discuss this flux code arc welding. From the name you can understand that the core of the electrode wire is consist of flux material. Basically, it is to replace where CO2 shielding is required. The FCAW performs better. So in some cases we have seen that for MIG CO2 is used. So in such cases, this flux code arc welding are performing better. Okay, so what happens here is the wire is a special type which consists of a flux coating. So if you look at the wire, this consists of a metal tube, metal hollow tube, and inside that, this is called flux, and this is hollow metal tube. Okay, now when this uh, welding is started, the arc is being produced from these metal tube to this workpiece, and in that arc the temperature rises and this flux at the core get burned up and produces CO2 and provides the shielding gas. So here the this is the principle. Now here in this case our equipments are a variable speed motor or motor control system which feeds the wire roll or the spool. Okay. Second requirement, a gun which houses a trigger to initiate and stop the electrode feed, and if separate flow of shielding gas if required, then that is also controlled by the gun. Okay, now next point, a nozzle is required which directs the shielding gas towards the molten metal pool. Okay, a power supply, source of shielding gas if required, or water supply which works as a cooling water if required. Okay, and the materials can be melted by this method. Weldable metals, these are low to medium carbon steels, low alloy, high strength steels, quenched and tempered steels. Number 4, cast iron, and few cases stainless steel. If we apply CO2 gas, then it will give you a deeper penetration and you can weld more thickness from 1.6 mm to 13 mm with no edge preparation. But if CO2 is not used, then you can use only up to 6 mm. So if extra shielding is used by CO2, up to 13 mm can be welded. If CO2 is not used, I mean extra CO2, then up to 6 mm can be welded.
5 পয়েন্টে কি বলবেন স্যার?
কোনটা?
5 পয়েন্ট 5 স্যার।
Okay, in few cases, the stainless steel also can be joined.
few cases.
Okay, their application is huge This is the all position process like MIG. Application. This is also an advantage of it. All position process. So you just need to find the proper filler material, and advantages like no shielding gap to be needed. So this FCAW is also used in underwater welding also. So here high deposit rate is also available, where high deposit rate is required. This is application and advantages together. Okay. For automotive applications, where high speed welding is required, less pre-cleaning is required, and here we get metallurgical, so metallurgical benefits. How? Because the slags produced here from the fluxes, those are lighter than the parent metal, and get they float over the molten pool. So as a result, they produce a shielding effect. But there are some disadvantages too. Disadvantages are melted contact tip. So the tip of the nozzle sometimes get melted because of the heat produced. So in the machines, sometimes uh, irregular wear feed happens. The porosity on the weld can be seen because of this shielding gas is producing with the which is mixing with the uh, dropping metal. When the material drops from droplets and dropping to the molten metal pool, it catches the gases, and as a result, when it gets solidifies, they causes porosity. Wires are costly than simple MIG wires, and this is less suitable to the work which is getting paint. So in automotive type of cases where the body of course getting painted, this is not
Sir,
suitable.
which is getting
Paint less suitable to the work which is getting paint. Okay, so now with this we conclude the FCAW. This is just theory. Here only the wire is the different from the MIG. The wire is uh, the made as such that the core is made of the flux. So the this is costlier, but this is advantageous in some cases where MIG cannot be used, like in underwater welding. This flux core arc welding is very very common practice. Now uh, we will discuss the other topics. Let me check out the syllabus. So with it, we have concluded the module number 1, and few portions of the module number 2 is also left. Half of the module 2 has been done. Okay. So we will now start with critical and precision welding processes. Those are plasma arc welding, which is called PAW. There is laser beam welding, LBW, electron beam welding, EBW, ultrasonic welding, USW. These four are main important ones, and also we have underwater welding and welding of plastics. Okay, so let us start with plasma arc welding.
सर लास्ट टाइम की बोल रहे हैं सर वेल्डिंग ऑफ
Plastics.
ओके सर
And before we go through that, there are welding of plastics, welding of ceramics, and welding of what else? Composites. So these ceramics, composite, plastics, these are similar. These are made with this plasma arc, these laser beam, electron beam, and ultrasonic. Ultrasonic is a very common use in welding of plastics. So, and also there friction welding is also used in plastics. So before we learn the plastics and ceramics and composites, we learn this type of special type of weldings first. There is a explosive welding also, that is a uh, solid state type welding. Let me give you a just an overview. So in explosive welding, we use explosives of finite strength. We know how much strength that explosive have if it detonates. So what we do, only lap joints are produced in explosive welding. This is a one piece of sheet, this is another say piece of sheet, and here this is the explosive. Okay, these explosives are placed in separate uh, ways. So now uh, this is what actually done over these two sheets. These I'm drawing another picture so that you can get a better overview. we keep some gap between, and this is a bunch of explosives, not a single one. This is a bunch. Okay. So initially, what happens? This and this get exploded, and as a result, this comes down and produce a huge pressure over here and makes the joint. Then the second one, after a certain few seconds or just about a moment, this second one get uh, blast and this joint. So as a result, it looks like this. So this is how the explosive progress and the joint also progress like this. Okay, is the process clear to you? This explosive burst one by one, and as a result, because of this pressure of the explosives, these two sheets here joint in this following this line. Is the process clear? Uh-huh.
Yes, sir. Yes, sir.
Okay. So this is just an overview. We just go through once. Okay, there is not much written in any books. Okay, so uh, because there is nothing to discuss, what you need to know is the explosives. So uh, as because this is not a very common thing to discuss or a very common practice to use it, so that's why much data is not available for our standards. This is the type of solid state welding. I have just given an overview. Okay, so now, okay, this is already 11:46. So if we start plasma arc welding, it will take at least 10 minutes. Okay, leave it today then. We will start on the next class with plasma arc welding. Any questions on today's class?
No, sir.
Okay, so then I will stop. I will end today's meeting. We'll meet you on the next class.